equations model pedadamu. Suppose let me take the very first simple case, that is variable seperable method. Variable seperable method. So let me take an example like this. dy by dt is equal to y by t. Suppose if you have a differential equation of this type, okay, then I will do cross multiplication. dy by y is equal to dt by y. Then I integrate on both sides. This will become ln mod y is equal to, this will become ln mod t, and then I can put some integration constant which is also of the form ln mod say c. Okay. Some people will have tendency to write some k also as constant, but because these two are in logarithm, natural logarithm, if you write that also in the logarithmic form, it will come into a nice form. Okay. It is only for mathematical convenience you are writing like this. Even if you write like this, that doesn't matter. Okay. So now if I write like this I can write as y is equal to t c, where t is the constant quotient of integration. So this is one problem. Now let us work out one more problem on the same lines. Suppose I have y dy plus t dt is equal to 0. Suppose if I have a differential equation of this form, y dy plus t dt equal to 0, then I will write this as y dy is equal to minus t dt, and say let me integrate on both sides. Okay. Now this will become y square by 2 is equal to minus d square by 2. Now I can write some constant. That constant I will write as say some c. Okay. Now this I will write as y square plus d square is equal to 2c. That means I am bringing this minus d square by 2 this side, then I am taking LCM. Okay, 2 is common both sides for both of things. So y square plus d square is equal to 2c. This 2c I would like to write in terms of say some r square. If I write in that form, what is the advantage is I can interpret now this as some equation of circle. Equation of certain circle. Okay, with 0 0 as the origin and say r is the radius. I can interpret it like that. If r is a real number, okay, then we can think it is a real circle. So this is one more example for the variable seperable method. Now let us go to one more example. Suppose if I have something like dy by dt is equal to y plus t by 2y plus 3t. If I have equation of this form, this equation we call as differential equation which is having say homogeneous differential equation we say. Why we say like that? That means we should know the definition of homogeneous differential equation. If you are able to write dy by dt as some function of y by t, in this particular case suppose if I take t outside, say from here on the top and the numerator long, so if I take t outside it will become y by t plus 1 and t is outside. Similarly if I take at the bottom it will come as 2y by t plus 3 here and t will come over here, dt will cancel. Okay, this is the dy by dt. Now clearly the right hand side is in the form of some f of y by t, is a function of y by t. So if dy by dt is in the form of this f of y by t, or suppose dt by dy is in the form of some function g of say t by y, okay, or maybe some h of y by t also. See, dt by dy can be in the form of some h of y by t also, or similarly here also this can be in terms of some p of d by y. Then also we can call it as differential equation which is homogeneous. Okay. Now to solve such equations, what to do? We will see. For solving such kind of equations, we do a substitution like this. First, let us put it as y by t plus 1 and this as 2y by t plus 3. Okay. Now I will substitute y by t is equal to say some u. Okay. Now this I will write as y is equal to ut. Okay. Now dy by dt, I will differentiate this. Dy by dt is equal to, now here we have product of two functions, so I will use something like uv rule. So u into derivative of this, that is 1, that means u into derivative of d, okay, this d, plus this into derivative of this, that is du by dt. So what you have is u plus d du by dt. Okay. So now I will substitute this into this equation. Okay. That means in place of this I will put this u plus d du by dt, okay, is equal to, on the right hand side this will become u plus 1 by, this will become 2u plus 3. Okay. Now why we have substituted like that? That is a question. The answer will become obvious just as you see the next step. Because by putting this kind of substitution, we are going to convert this homogeneous equation into variable separable method, which we have already seen. Okay. The variable separable method we have already seen. Now this is the homogeneous thing we are doing. Okay. So what I will do, this u I will take that side. So it will become minus u. Okay. I will remove this. I will put here as minus u. So when I take LCM here, this will become u plus 1. Okay. Minus 2u square minus 3u. Okay. Divided by 2u plus 3. Okay. So I will remove all this now. Yeah. Now you can see this is t du by dt is equal to, this side you have minus 2u square. So I will take minus outside. It is like 2u square plus, now u minus 3u is minus 2u. So all the minus I have taken outside. So it will become 2u. And you have plus 1 here. So that will become as minus 1. Okay. So minus 2u square and then minus 3u, this u. Okay. So and then this is divided by 2u plus 3. Fine. Now let me just take cross multiplication. This will become 2u plus 3 by 2u square plus 2u minus 1 is equal to minus dt by t. Okay, dt by t. Okay. So once you have manipulated this, you have got this much. Okay. Now you can clearly see, and this side what is there? Du is there. Du. So you can see now this has come into the variable separable form, because all the u terms are one side and all the t terms are on the other side. So now you can do integration on both sides. So when you do the integration on both sides, you are going to get like this. Okay. Now here we need to find how to do for this, and on the right hand side it is like minus ln mod t plus, you can even say ln mod c, which is the integration constant that you can directly write off. Okay. We will write next anyhow. So this part is quite obvious, and for this I have to do some kind of adjustment. I have to see. Yeah, we will see that part in the next class, as the time is up now.